So the reality is that what we did before was we just plotted 2 points and we just visually figured it out by going up and over. But just imagine if the points were really, really far from each other. Hypothetically, we're not going to do anything like this, but just imagine if they were like hundreds of units away. It would take a long time to count all of those grid lines. So there's a more efficient way to do it, and that's what we're going to look at. So going back to looking at a line, let's take a look at this one right here. So the top point is 2, 8. The bottom is -3, -5. So what I want to show you today is, I guess you could call it a shortcut to figure out the slope. So what is the y value of this blue point? -5, okay? And what's the y value of the red point? 8. So instead of actually counting all the way up to the red point, if we just take this y value and subtract this y value, we can quickly find out what the vertical rise is. So what I'm going to do is do 8, which was the top y value, go back down and see the bottom y value is -5, so we're going to be subtracting a negative number, which becomes 8 plus 5, which becomes 13. And if we want to verify that, we can actually count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? But the point is, we don't have to do that because we can just subtract the y values. Now we're going to call this number right here our second y value because it's to the right. We talked about this, our second point we choose. The first point we choose is the first y value. Okay, so our first y value is -5, the second is 8. And if we just do y2 minus y1, we actually get the change in y. The way we would write that, this is very important to write this down. We talked about the fact that this means change in. It means that the change in y is just going to be y2 minus y1, no matter what. Okay, so make sure you write that down. It's very important. It's just like we talked about yesterday. If you were hiking, if you went up a mountain, that'd be your y2. Your y1 would be where you started. You subtract those two, and that gives you the change in elevation from where you started to where you ended. So going back to now, if we want to look at the change in x. Okay, let me actually make a little doodle here for what we just did. So we actually went up 13 units. And the way we did that was we did 8 minus -5, and if you count that, you get 13. Okay, the way to find the change in x is if you just take the second x value and you subtract the first. What do you think that gives you? 1, 2, 3, 4, 5, right? Okay, and the way we're going to write that is the second x value, which is 2, minus the first, which is -3. So the change in x is going to be second x value minus the first. And that becomes what? 2 plus 3, which is 5. So again, what that would be is x2 minus x1. In general, change in x will always be that. Okay, so it's pretty simple. Change in y is just the second y value minus the first. Change in x is just the second x value minus the first. And it really doesn't matter what we do with this. I mean, we can maybe move it more like this. You can still see that the vertical rise here would just be 7 minus -6. If the negative confuses you, we can move the second point up to the first quadrant. So here we'd have, for the y, it'd be 7 minus 2, which would be 5 units up. And then to get the change in x, it'd be 5 minus 2, which is 3. Or we can move the line over here. To get the vertical rise, you could do 7 minus 0, which is 7, so it goes up 7 units. to get the vertical, the change in x, you could just do 4 minus -4, which would be positive 8. You would always do the second, the one on the right, which is 0.
The second one on top.
Say that again.
So do
Well, you do the second minus the first, so it'd be 0 minus 7. If you notice, it goes down 7. The one on the right, the y value on the right minus the y value on the left. Okay? Okay, so now that we've talked about that change in y is y2 minus y1 and change in x is x2 minus x1, you guys already have written this down, but what you need to write down is, since that's change in y and that's change in x, then slope is just that. Slope is just y2 minus y1 over x2 minus x1. It's just literally the change in y over the change in x. Now, the reason I'm teaching this second example is just, listen up. Imagine if you weren't given a graph, you were just given 2 points. Especially if those 2 points were really far away from each other. It would take a long time to graph that and count every single line, right? So the formula is useful and even a lot quicker when you have bigger values. Or if you, for example, had a decimal or a fraction, the graph method like we did yesterday would be pretty tedious. So anyways, step 1 is still going to be the same. We're going to plot 2 points that are on the grid. The first one I notice here is 3, 2. Whoops. It's hard to get it right on the thing. Here, let's try it this way. Okay. And then there's another one, looks like right here. So I'll plot that one right there. And I think those are as close as they possibly can be. Yep. So there's probably more than one solution there, but we'll go ahead and choose those 2. Now the next thing is a little different from yesterday. We're going to label the points. Okay? This first point is what? Whoops, it's not going to work too well. Actually, we're going to do the one on the left first. That was my mistake. Yeah, -2, -2. Now, before I go on, guys, we need to actually label the point. Okay, the point on the left, you're going to label x1, y1. Whoops. Okay? And then we're going to go to the next point, which is going to be 3, 2. And what do you think that's going to be labeled? x2, y2. Okay? So there's step 2. Step 3, we're going to write out the slope formula we just learned. And you guys can start to use the letter M. Again, I don't know why we use that for slope. We just do. Probably stands for something in another language. Slope is going to be y2 minus y1 over x2 minus x1. Some people might ask, could you do it the other way around? Yeah, you could do y1 minus y2 over x1 minus x2. That does work. I don't know why you would, though. It's easier to think about the fact that you're taking the second value and subtracting the first. Okay, then you're just going to plug in those values. So that's why we label the points. What is y2? It's 2, right? It's right above the value. Okay, so you're just going to plug in 2 there for y2. Just like that. y1, -2. Now, notice, you're plugging in -2 for y1. Okay? Notice that's a double negative. You're subtracting a negative value. So I'm telling you right now that for each of these, you need to put them in parentheses. It's literally just replacing y1. If you don't do that, that's on you, not me. x2. x2 is right here. It's 3. Put that in parentheses. and I'm going to be subtracting x1, which is also negative 2. So again, I'm putting that in parentheses and making sure it's negative.
What you're saying is it makes it easier.
Yep. If you don't do that, I guarantee you'll put 2 minus 2 is 0, and you'll say the slope is 0, and it's just the way it goes. So step 4, once we write the formula, we plug in the values, and now we just solve. So the top becomes 2 plus 2, yes, because it's 2 minus negative 2. The bottom becomes 3 plus 2. And the slope becomes 4 over 5. And again, when you get this answer, make sure it's simplified, okay? So what we figured out, and I'll go back down in a second, but what we figured out is it goes up 4 and over 5. All right, example 2. Negative 4, 4? Okay, how about negative, okay, that's fine.
Or it should be negative 2, 1, or negative 1, negative.
Yeah, negative 4, 4 is fine, and then the next point would be negative 3, 2. Those are pretty close to each other. Now, I know you can look at this one and tell, but we're doing this for a reason. You were doing the math, exactly. So what's that first point? Well, we just said it's negative 4, 4. And again, we want to label that point. So that is my x1, y1. Okay, the next point, I'm going to have to go over here, is negative 3, 2. And that is the x2, y2. Okay, so we've plotted the points, we've labeled them. Again, we're just going to write the slope formula out. Okay, then we're going to plug in those values, making sure to put them in parentheses. y2 is 2, and y1 is 4. So it's kind of like this, 2 minus 4. We're literally just plugging those in for y2 and y1. Okay, then we have x2 and x1, which is negative 3 and negative 4. So negative 3 goes in for x2, and negative 4 goes in for x1. So we're subtracting a negative on the bottom. That's step 4, plugging them in. Now we're just going to solve. What's 2 minus 4? Negative 2. I'm going to go ahead and do this in 2 steps. So minus negative 4 becomes positive 4. And then finally, we get negative 2 over what's negative 3 plus 4? 1. Which, if you want to simplify, would be negative 2. But anyways, you can kind of see that it does go down 2 over 1. Okay? But again, this is kind of like a transitional lesson because graphically, normally, it's easier just to go down and over. But on Monday, I'll just be giving you 2 points, and some of them will be far away from each other. It's just easier to plug into the formula.